and we select the curve, Control select the center of the circle, add the pierce relationship. Now the circle moves to a different part of the curve. So curve from the feature manager doesn't allow you to select a location on the curve, which can cause problems like this and put you in a situation where you have no control. In cases like that, use a 3D spline instead of the curve feature. In this lesson, you'll learn about equation-driven curves. Equation-driven curves are actually 2D sketches in SOLIDWORKS. They are available through the menus under Tools, Sketch Entities, and then Equation-driven curve. You can put this on the curve drop-down if you like, but you have to show the curve toolbar. So we'll right-click in the toolbar area, show the curve toolbar, and then go to Tools, Customize, Commands, Sketch, and grab the equation-driven curve and drag it over to the curves toolbar. While we're here, we might as well get the intersection curve, which is a 3D sketch rather than a 2D sketch, and the face curves, which are also 3D sketches. We'll say OK on this, and now when we hit the drop-down, we have the additional tools on this drop-down menu, and we can get rid of the curves toolbar. So let's start an equation. SOLIDWORKS is prompting us to select a plane. So we'll pick a plane. And we have two options when creating an equation-driven curve. An explicit equation would be y equals x squared. And parameters just mean the start and end values for x. So we could say -2 and +6. When we click OK, SOLIDWORKS creates a spline parabola for it. And that's nice, but that's a 2D sketch. Let's look at the other type of equation. Let's change this to parametric. A parametric example of the parabola would be x of t is t, and y of t is t squared. And the parameters for this would be, again, the start and end values for the parabola. So let's say -1 and +1. And the curve is right on top of the previous one, using a subset of the values. So those are equation-driven curves, only available as 2D sketches. The two other types of curves we want to investigate in this lesson are the intersection curve and face curves. To use the intersection curve, let's open up the model from your Chapter 3 files called Intersection Curves and Face Curves. This is just a copy of the full we've been using for several examples. Intersection curve has two possible functions. One is in a 3D sketch, and the other is in a 2D sketch. For example, if we were to open up a sketch on the front plane and use the intersection curve, SOLIDWORKS is prompting us to select several faces. When we click OK, SOLIDWORKS creates a series of 3D splines that show where the current sketch plane intersects the selected faces, and these can be solid faces or surface faces. The other type of intersection curve you can get in SOLIDWORKS is the intersection between any 3D faces. So in this case, we have a three-dimensional face that was created inside the model, and I want to see where this intersects the helmet model. So let's go to open up the intersection curve tool, and I can select the face of the surface body and several other faces on the part. When you're done, click OK. And SOLIDWORKS creates 3D sketch splines at the intersection of the two faces. These tools are extremely handy in situations where you need to know where faces or planes intersect with geometry. These are very powerful tools that can help you solve complex geometrical problems. Face curves represent the underlying structure of a particular face. Let's hide the plane and this other face to have a look at exactly how face curves work. If I were to select on a face that was created in the course of making this helmet, and then use the Face Curves tool, SOLIDWORKS shows us the underlying mesh structure of the face. We can change the number of lines in either direction, and this will visualize if there are any difficulties with the surface. You can also select a single line by using the position option and positioning this in a particular point. This can help you create a 3D spline that lies directly on the surface, allowing you to create special geometry. If you click the green check from the Face Curves Property Manager, SOLIDWORKS will create a series of 3D sketches that lie within the model on the face. You can use these to rebuild a surface or create new features.